Learn controls by simulation, a delineation of what goes on behind the process. I retired from GE in 2016. I learned a lot through simulation. I hope you will too. System set up on a typical GE site with Mark 6E. We will start on gas, simulate a trip during warm-up. Troubleshoot. Start again on liquid fuel. Then we go into detail in section 3 on load control. And in section 4 on temperature control with inlet guide vane biasing. In this section we show a typical setup on a GE site with Mark 6E controller. So how does a click on the HMI becomes a start command to the controller? It's all down to Ethernet Global Data or EGD communication. EGD servers and clients producing and consuming global data. GT1 program downloaded to the controller is the EGD producer. CRM1_server, the master workstation, and GT1_server, the local workstation, are the EGD consumers. EGD configuration is done in Toolbox ST, as shown here. G1 program produced these pages of EGD. The workstation's reference, or consumes G1 EGD. A click on Start PB on the HMI startup screen sets EGD variable on the workstation to logic 1. EGD variable L1 start_CPB gets updated in GT1 program. GT1 program processes the command, and if the logic permits, sets L4 to 1 to start the turbine. Thank you for watching section 1. Hope you come back for section 2 when we start the simulation. In this section, we will start the unit on gas fuel. Simulate a trip during warm-up. Troubleshoot the cause of trip. Then we start again, but on liquid fuel, and run to full speed no load. We switch to the startup screen on the HMI, and start the simulation. Unit is on cooldown. Starting clutch is engaged. The hydraulic ratchet motor starts, ratchet goes on a forward stroke and the turbine shaft rotates. At the end of the forward stroke, motor stops, ratchet retracts. The cycle continues, once every 3 minutes, until the cooldown timer times up, and the operator press the cooldown off button on the HMI. Select to auto. Click master reset. Select to gas. Go to trip diagram 1 and check no trips. Go to trip diagram 2 and check no trips. Go to start check page and check start permissives. No trips and no start inhibits. Go back to startup screen. Select start and OK. The diesel engine starter waits for 0 speed to crank. Cranks 1 to 3 times to run to idle speed, for warming. The diesel engine starter runs at idle speed for 2 minutes to warm up. Observe. Inlet guide vanes are at full closed position. Compressor bleed valves are opened. You can click on Start Trend to run a startup trend. Click on Turbine Data to view important parameters during startup. The diesel engine starter warm-up is complete. It accelerates to crank up the turbine. The turbine cranks for 10 minutes to purge the turbine and exhaust of residue gases. Go to Motors to check what auxiliaries are running at this stage. Click on Motors. Observe the purge countdown time here. Igniters are turned on, SRV and GCV open to start fuel position, P2 pressure increases, flame is detected. The turbine is at warm-up. Warm-up time is 1 minute. In the meantime, we can look at the startup trend. This is the trend of a successful start on gas fuel. L4 equals true. Turbine is started. Diesel starter speed runs on idle for 2 minutes, accelerates to 100% to bring the turbine up to crank speed, pulls back to 75% for ignition. Goes back to 100% speed after warm-up to assist the turbine to accelerate to full speed. Igniters turn on after purging is done. GCV and SRV opens to start fuel position. Interstage pressure P2 increases as speed increase. Turbine speed goes to crank speed after diesel starter warm-up is done. Stays at warm-up speed for 1 minute after ignition. Accelerates to full speed when warm-up time is up. Starting clutch is disengaged at about 60% speed and diesel engine starter is stopped. Let's go back to the HMI and see how the turbine is doing on a warm-up. Turbine is tripped. Troubleshoot. Go to the HMI and click on Alarm Viewer. If the event happened sometime back in the last 30 days, click on Short-Term Historical Alarms. Otherwise, locate the alarm in Live Alarms. P2 pressure high trip is alarmed. Right-click on it and select Go to Definition in Logic. Check in Toolbox ST, how is P2 high trip triggered in the logic? What is P2 pressure? P2 is the interstage pressure between SRV and GCV. It is checked during warm-up, on the startup on gas fuel. It depends on SRV and GCV opening and the fuel supply pressure. GCV regulates the fuel to the turbine. SRV is regulated to maintain P2 to its reference. As GCV opens, SRV must be opened more to maintain P2, and vice versa when GCV closes. P2 reference increases as speed increases. Based on this formula, turbine trips if P2 is higher than the high limit during warm-up, or lower than the lower limit during warm-up. Go to the trip log to investigate what caused this trip. Navigate to the trip log directory. The file name for the trip log is in UTC. The modified time in Windows Explorer is in local time UTC +8. Double-click on the trip log file name. Select No. And add as required. Select variable name G1.L4. Add more tags, as necessary. Zoom in on the selected tags. Note speed and P2 pressure at point of trip. So what caused the trip? Did P2 exceed the high limit at point of trip? Or P2 reference is wrongly computed? Not sure? Go start on liquid. Before we start on liquid, let's review the liquid fuel and air atomizing systems. Fuel forwarding pump is turned on as soon as turbine is started. Fuel forwarding pump stop valve is opened 5 seconds later. Fuel forwarding is located off skid and not displayed on the HMI. On ignition, fuel pump clutch is engaged. Fuel stop valve is opened. Fuel divider motor is turned on 10 seconds after. It is turned off at about 50% speed. Isolating valve for the start air booster is open to assist the main air compressor during starting. It is closed when turbine reached 100% speed. Bypass valve for atomizing air compressor bypass. It is open on liquid fuel operation. Closes when on gas fuel, allowing compressor-less purging airflow. Select auto. Master reset. Select liquid fuel. Check for ready to start status. Press start. Go to liquid fuel screen. Fuel forwarding pump has started and the stop valve opened. They are located off the turbine skid and not indicated here. The on-skid fuel pump clutch and stop valve are still closed. Go to the atomizing air screen. The starting air isolating valve is opened. It is closed at 100% speed. The bypass valve stays open during liquid fuel operation. Diesel engine is on a warm-up. Go back to the startup screen. Diesel engine starter warm-up is done and accelerates. Turbine breaks away and goes to crank speed. Purging continues for 10 minutes to rid the turbine and exhaust of residue fuel. Waiting for ignition? Go back to liquid fuel screen. Turbine is ignited. Pump clutch is open. Fuel oil stop valve is opened. Turbine is at warm-up for 1 minute. Turbine is accelerating to full speed. Let's look at the startup trend. This is the trend up on liquid fuel. Diesel starter speed. Fuel forwarding motor turns on when turbine is started. Fuel forwarding stop valve opens 5 seconds later. Turbine speed. Start air booster motor turns on when turbine breaks away. Igniters are turned on. Fuel pump clutch turns on at ignition. Fuel stop valve opens. Flow divider motor turns on 10 seconds later. Turbine is at full speed, no load. Isolating valve for starting air is closed. Thank you for watching. Hope you watch the next 2 sections, load control and temperature control with IGV bias. Contact me for more training.